Question 14. Draw a section of polymer from each of the monomers shown below. Obviously, you need to see that this is an alkene. CH2, CH2. You definitely need an alkene because you need the double bond in order to form a polymer. But when you have a semi-structure or condensed formula, it's a good idea to start by drawing exactly what it is, which is a C, bond with another C, and you have 2 hydrogen per carbon. And obviously, in order for it to work, it must have a double bond here. You don't want to presume that it has a double bond before you check the number of carbon and hydrogen. I need to draw a section of the polymer. So this is a very specific request. You're not going to draw the formula, you're going to draw a section. So it's going to have dot, dot, dot on both sides. Okay, this is an easy one. Try to set out so that the double bond is the backbone and everything else is moved either up or down. It makes it a lot easier to draw the polymer because all you need to do is to break the double bond. So I'm going to have the hydrogen exactly where it is originally, and then I'm going to link this monomer with another monomer that also has the double bond being broken, like that. Now, it doesn't really say how many monomer I need to draw for a section, so I can really stop with 2. What I really don't like though, and I'm going to fix, is this one, because I don't like how the hydrogen kind of does not look like it is linked to the carbon. So I am going to fix that before I move on to the next question. So that's fine. Feel free to add another monomer if you want. You probably don't want to stop at 5 carbons or like 2.5 monomers though. That's kind of weird. So if you're going to add a monomer, add the whole thing, don't just add half of it. Okay, part B. So once again, I know that I need to have CC here. So you have H2, and then you have a H, and then that has to be the chlorine. And in order for this molecule to work, you must have a double bond here. So that's good. Okay. C, C. So we have H, 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 and Cl. And this is linked to another monomer. I'm just going to start with 2. Don't worry about the locations of the chlorine. You can definitely have it up here, or you can have it here. As long as you have 1 chlorine per monomer, that's okay. Because in reality, there are multiple ways to control the location of these side groups or branches. So it's okay. Don't worry too much about it. All right, we have this one. This is not bad. Like the location of the monomers is okay. But if you want it to be a little bit more obvious, I'm just going to redraw it. I'm going to redraw this monomer. So I'm going to have the C double bond C. That's my backbone, and I'm going to move everything else either up or down. The question doesn't say, therefore I am going to condense it a little bit just so that it's not too messy. So the CH3 is up here, and then here it's a bit of a pain. You have a C double bond O followed by a CH3. This is a little bit easier to draw, but you really don't want it to be this big and bulky, and it's gonna take too much space. All right, and then you just break it. H, H, and then we have a CH3 up here. You have a C double bond O followed by a CH3. Sometimes I make this a little bit longer just so that the result is not too crowded. Once again, don't worry about the location of the branches. As long as you have the correct number of branches per monomer, that's okay. But I tend to just keep it the same way. It's a little bit easier to draw. I mean, you don't really need to think about these things. Okay, that's it. Alright, this one definitely will benefit from a little bit of redrawing of the monomer before you get to the monomer. So you start with N, and the C double bond C. So this C double bond C, this is my backbone. Everything else will be moved. So this hydrogen go up here. This hydrogen go up here. Now this whole group CH2, CH3, I'm going to bring it down here. So I have a CH2 followed by a CH3. Alright, so this whole group goes here. And then you have this. Now this has a H. In reality, the H tend to come down and then the CH3 come up. I won't penalize you if you do it the other way. It's okay for now. Alright, so that's the monomer, which makes the task of drawing the polymer a lot easier. All you need to do is just repeat it. Make sure you break the double bond between the carbon. 1, 2, 3. Okay, there's a CH3 here, and there's a H. So this is my first monomer, and then it's going to be followed by another monomer. I'm just going to keep the structure of any branches the same, just to make it a little bit easier. Okay, and we're done. Is that it? Okay, that's it.